Hi everyone, my name is Lauren.
And my name is Jade. We're undergraduate students at Cornell University studying computer science.
Our research focuses on the impact of extreme weather conditions on the severity of motor vehicle collisions in New York City.
Traffic collisions remain a serious public safety issue. The U.S. Department of Transportation Highway Administration seeks strategies to reduce crash severity, and our goal was to explore how weather factors influence the severity of motor vehicle collisions.
So first, we analyzed data from the New York City Open Data Motor Vehicle Collisions dataset alongside comprehensive New York City weather data from recent years. We examined key weather factors including precipitation, snow depth, and temperature, and their correlation with crash severity.
To ensure accuracy, we handled missing or incomplete data using imputation. We defined collision severity by weighing the number of injuries and deaths accordingly.
For extreme weather conditions, we decided to establish different thresholds. So for high or extreme heat, those were temperatures above 90 degrees Fahrenheit. For heavy precipitations, that was zero point 0.5 inches or more of rain. And for significant snow depth, that was 4 inches or more. And using data visualization, we aim to identify whether these extreme conditions contributed to increased crash severity.
Our visual analysis showed no significant disparities between normal and extreme weather conditions except for extreme heat. However, when we examined the average severity of crashes, we found notable patterns. So first, heavy rain correlated with higher crash severity, possibly due to reduced visibility, slippery roads, and driver misjudgment of wet conditions, especially in flood-prone areas. Second, snow depth had an inverse relationship with severity, meaning crashes during snowy days were generally less severe. A possible explanation is that either fewer people were driving or they were driving more cautiously in heavy snow. And third, temperature had a strong positive correlation with crash severity, so higher temperatures led to more severe crashes.
One possible explanation for the heat crash correlation is road degradation. High temperatures can often soften asphalt or cause cracks, making roads unsafe. Additionally, heat stress can impair driver judgment and reaction time, increasing accident severity. So, following our insight on higher temperature correlating with more severe crashes, we decided to pinpoint specific areas in New York City where this correlation was most prominent.
To do this, we created a heat map of average crash severity on days of normal temperature and another one on days with extreme heat. Based on our heat map, we saw a concentration of more severe accidents in the Flatbush/Midwood area of Brooklyn, and from this we could draw that the Midwood-Brooklyn area may be more susceptible to severe collisions on days of extreme heat.
Extreme heat can cause pavement issues like softening asphalt, cracks, and surface deformation, creating hazardous driving conditions. Poor road maintenance and lack of shaded areas further contribute to driver stress and impaired judgment. To mitigate these risks, specifically in Flatbush/Midwood area, we recommend the following actions. Number one is to conduct routine heat-related road inspections to identify and repair softening asphalt and cracks before they worsen. Number two is to use heat-resistant materials such as polymer modified asphalt in road resurfacing projects to improve durability under high temperatures. Number three is increase shaded infrastructure by planting more trees along sidewalks and near roads to reduce heat buildup and extend road lifespan. Number four is to encourage drivers to use heat-resistant or all-season tires that can maintain traction on hot pavement and withstand high temperatures. And lastly, number five is to implement tire pressure monitoring campaigns, as heat can cause overinflation, which increases the risks of blowouts. And local gas stations and service centers could offer free tire pressure checks during the summer months.
Next, heavy precipitation increases crash severity, especially in flood-prone areas. To enhance safety, the city should consider the following recommendations. The first is to improve road drainage systems by clearing debris from storm drains and upgrading high-risk areas with better water runoff management. Second, apply anti-skid materials on frequently wet roads to enhance traction and reduce hydroplaning risks. Third, install weather-sensitive traffic signs that display warnings and speed advisories based on real-time rain conditions. Fourth, require rideshare and commercial vehicles to use tires with deep tread patterns and water channeling capabilities, such as rain or all-season tires to improve safety in wet conditions. And lastly, launch public awareness initiatives, including driver education programs on safe braking distances and speed reduction during heavy rain.
By implementing these targeted, actionable steps, the city can reduce crash severity and improve overall road safety during extreme heat and heavy rainfall.
So, our research highlights that weather conditions influence traffic collisions in multiple ways. While extreme weather doesn't always increase the number of collisions, it significantly impacts their severity.
And by implementing data-driven safety measures, we can help reduce the severity of crashes and improve road conditions based on regional weather patterns.
And thank you to the Northeast Big Data Innovation Hub and National Student Data Corps for the opportunity to present our findings.
And thank you all for listening. Bye.